Hey guys, welcome back to our channel. So today we are going to solve the problem majority element part 2. Okay. So what does a majority element is? It means any element which appears more than n by 3 times in an array and where n is the size of the array. Okay. So we have done a similar question if you guys remember, that is majority element part 1, in which we have to find the elements which appear more than n by 2 times. So in this part 2 we have to find elements which appear more than n by 3 times. Okay, so for example we have this 3 to 3 where that means the size of the array is 3, and if we do 3 by 3, that means 1. So any element which appears more than once, we have to return. So here 3 is appearing 2 times, that is greater than 1. So we have returned the 3. Okay. So now let's think of the all the possible approaches to form the solution of this problem. So we are given this array 2, 1, 1, 3, 1, 4, 5, 6. Right. Now what we have to do is we have to find all the elements which are appearing n by 3 times or more than n by 3 times, right? So before we start, right, let's understand few things in this question. Okay. So that means is how many possible elements can be there? Okay, because if we have to find all the elements greater than n by 2, that means which appears more than 50% in the array, right? So there is no chance that there can be more than one element, right? In that case, it is always for sure that there will be only one element, right? Now let's see, how many elements or the maximum number of elements which are possible if we are looking for n by 3. Okay, so just try to understand this. Okay, so what I meant by this is, let's say I have, n equal to 8, right? This is what I have. And if I, let me make it big for you. Yeah. So we have n equal to 8, right? And by simple mathematics, if I do 8 by 3, I will get 2.66, right? And if I do the floor of it, I will get 2, right? So basically, and if I'm looking for greater than 2, right, that means 3. So in total of 3, if I find one element, right, it is taking 3 places. If I find one more element, it is also taking 3 places. So the total will be, and if I find one more element, it will also take 3 places, right? So like 3 places for one element, 3 for another, 3 for another, which becomes 9, right? And our n is of size 8, right? And our total is becoming 9 if we take 3 elements. So what does it mean? It means if we are looking for, n by 3, if we are looking for greater than n by 3, that means a max of 2 elements are possible. Okay, so this is the thing which we have to keep in mind from starting. Okay, because see, if we know how many elements we are looking for, then it will be easy for us to maybe optimize it or find the solution. Okay, so there will never be the case that we are exceeding the 2 elements. Okay, so keep this in mind always. Okay, let me place it at the top. Okay, now, so this we have to keep in the mind. Okay, so now let's start from the very basic approach. Okay, so let's assume we are starting from first element, that's it 2. Then what we can do, we can search for 2 in the whole array, right? And if we find the 2, we can maintain a count, right? I found 2, right? And let's say this is my element. Okay, right? If it is the element and I start with the 2, I will start looking for this 2. 2 is here now. Is it 2? Yeah, first element is 2 that I know, so the count will be 1. Now I will look for the in the whole array. 2 is there? No, 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 no. So the count of 2 is 1, and I'm looking for elements, greater than 2, right? That is 3. So I will move to the next element, that is 1. Now what I will do, I will again search in the whole array. Is it 1? No. Is it 1? Yes. So I will increase my count to 1. Is it 1? Yes. I will make my count to 2. Is it 1? No. Is it 1? Yes. I will make the count to 3. Right. And now I can see my count becomes greater than 2. Right. So that means this 1 is appearing n by 3 times. I can take it as my answer. Right. Now again, what I will do is I can skip this one and I will start from 3 and so on. I will search in the whole array, right? So in this way, in the most, naive way, we start from the element one by one and then start looking for the element in the whole array, right? So what we have done in this, to start traversing the array, we are using a loop that will run from 0 to n, right? And to look for the ith element, right? We are running more loop to look for the ith element in the whole array, right? So basically we are running two nested loops of length n, and which means my time complexity will become O n square, right? This is very basic approach and the most brute force one, and I think you will be able to understand this, right? We are doing nothing, just iterating the array, and for each element we are again iterating the array and just calculating its count. And we are not using any extra space, so that means the space complexity will be O1, right? But you know, this is not the solution, right? That you must be expecting, right? That we have to loop, have two loop and then, find the majority element which appears more than n by 3 times. And, the time complexity is n square, right? And it is a way too high, right? We have to look for an element and we are taking n square. So let's think of, better approaches, how can we make it better in the upcoming ones, okay? So now let's think for the better one. So now we have done the brute force approach and that was quite simple. We just looked each element one by one in the whole array, right? So now let's think of a better approach, right? Till now we have done so many problems in our array playlist, and whenever, we are in this kind of situation, we are always stuck in, we are looking for something which is, greater than n by 3 times or n by 2 times or, anything, right? The most common thing here is we are looking for something, some occurrences of the elements, my result lies in if any element occurred more than n by 3 times, then I am happy with it and I will take it, right? So that greater than n by 3, right? This occurrences, okay, whenever we talk about count and occurrences of the elements, the best thing we have to do is hashing, okay? We can maintain a hash table, okay? So let's start. Let me assume this is my hash table, okay? Now it is very now straightforward, okay? What we will do is we will just store the occurrences, okay? Let's start with 2, okay? We are here in the 2 and we will look for the 2 in our hash table. It exists. Now we will make an entry of it and make the count of 2 as 1. Correct? Now moving to the next element, we will see is 1 exists in the hash table? No. We'll make an entry of 1 and make the count of 1 as 1. Right? And whenever we are making an entry or anything, we will also compare because n by 2 is 2. I'm sorry, n by 3 is 2 here in our case as n is, 8. Right? So we will always compare after each entry that, is it greater than 2 or not? Okay. Now going to the next element. Is 1 exist in this hash table? Yes, it do. I will think that means I can increase the count of 1 by 2, basically plus 1. Then I will check is this 2 is greater than 2? No. I can move on. Now the next element is 3. So let's see if 3 exists in our hash table. Nope, it doesn't. Let me make an entry of 3 and make it 1. Right? Now again, I am having a 1. Let's see if this 1 exists. Yes, it does. I will increase the count of 1 by 1 and will make it 3. And as soon as I make the count of 1, 3, I will check if this is greater than 2. Yes, it does. That means I can use it as my majority element and I will store it. Okay, this 3. Now, no, not this 3. Basically, the element is 1, right? 3 is not the element. Count is 3, right? I will store the element. Now, let's move to the next element. That is 4. Is 4 exist? No, it doesn't. Let me make an entry of 4 and make it count as 1. Right. Now, moving to the next element. That is 5. 5 exists? No, it doesn't. I will store the entry of 5 and make it 1. Now again moving to the next element, does 6 exist? No, it doesn't. I will insert this and I'm done. So we have done with the occurrences, and while inserting each element or checking each element, we will check the occurrence. If it is more than r n by 3, that is here 2, we will insert in an array, and once iteration is done, we can return the answer. Okay. So this concept is very, simple. Now you people must be used to of it. Whenever we talk about occurrences or counts and we have to maintain it, we can just use hashing to avoid the n square of our time complexity, right? So this is pretty straightforward. And now I know you must have guessed that time complexity should be of n, as we are just iterating through this array once. And as we are using our hash table and we are storing all the elements here in the worst case, so it should be of n space, right? So this is the time and space complexity. And here we have successfully, reduced the time complexity, right? And it is really good, right? Good job. Congratulations. But we have also increased the space complexity, right? Earlier in our brute force approach, it was of 1, but now this time we have reduced. We now not reduced, we have increased our space complexity. That is till of n, right? Now let's think, is this the only better solution or the optimal solution we can think of, or is there a way, to reduce the space complexity as well, right? So now let's think how we can, maybe reduce the space complexity and make the overall complexity of this, solution a better one. So till now we have seen the two approaches, the brute force and the hashing one. And in the hashing, we successfully reduced the time complexity as of n, and we got a, increased space complexity as of n. Now let's see, how we can maybe, make it better. Okay. So I have told you earlier also that, similar kind of a problem in which we have to search a majority element of greater than n by 2. We have done it earlier also. Okay. And if you haven't watched that video, then please do watch that out, because now we are taking inspiration what I have told you in that video. Okay. And if you have remembered this, that, and there I have told you one algorithm for this, the most optimal solution. And that algorithm was Moore's voting algorithm. Okay. And I will be using, we will see how we can use that algorithm, or we take inspiration from that algorithm to make this approach better here also. Okay. And if you haven't watched that video, then please watch that out and, get the intuition of that algorithm. So now let's combine that here in our question and let's start. So, and if you guys, you know, don't remember or, forgot, then let me make it easy for you. Uh, yes. So for that, and the algorithm was Moore's algo, right? If you remember. And let me increase the size. Yeah. So basically in that algorithm, let me, make write a pseudocode for you. what we have done is we have taken two variables, that is count and the element. Okay, and this is, let's say, minus infinity. So what we are doing in that algorithm was that we are looping for array, right? And let's say n is my length of the array. And what we are doing was, if by any chance count equal to 0, right? That means we are getting a new element, and we can increase our count by 1. That's what we did last time. And we can initiate our element as, this, let's say, nums is one array, nums of I. Otherwise, if my this nums of I equal to L, that means I got the same element again. And if I got the same element again, I will increase my count. Otherwise, in all the other cases, that means I am getting a different element, I will decrease my count. Okay. So this was my algorithm, more sorting algorithm for n by 2, right? But here, as and that time we know that only one element will exist, so we have taken only one. Now this will come, this concept that I told you, how many elements are possible, that will come into the picture. Okay, now we know elements are possible, right? Let's try to modify this algorithm as per two elements, because now we know this EL, it is for one element, because for n by 2 only one element was possible. Here a max of two are possible, right? So that means we have to modify this algorithm. Okay, now let's try, can we modify this algorithm for two elements as well, right? Let me make it better for you. Let us maintain two count variables now. Okay, count 1 and count 2. Instead of one EL, let's maintain two elements, two element variable, EL2 also as minus infinity. Okay, so what we have to do is, if count 1 is 0, we will increase the count 1 variable, right? And this EL, correct? And what we have to do is, again, for the count 2 also we have to write the same. If count 2 becomes 0, that means what we have to do is, we have to increase the count 2 as 1, and we will maintain element 2 as nums of I, correct? This we have modified. Now, this nums of I is equal to element 1. We will increase the count 1. And if this nums of I equal to element 2, what we will do is, we will increase our count 2, right? And in all the other cases, that means if count is more than 0 and element is nothing, like, equal to none of the two, we will decrease both our counts. Okay, so this is kind of algorithm that we got, if we modified, is as per our question. Okay, this is the most algorithm that we have devised for two numbers, right? Because we know. Now let's try this. Does it really work, or we need to make some more changes, right? Because now what we have done is, we have just blindly extended this algorithm for two elements. Okay, now let's start running this. I am at my element, first element is 2, right? Now let me initialize the variables, that is C1, and let's say this is my element 1, E1, and this is my C2, and this is my element 2, right? That is E2. So these are my four variables. Now let's start. Okay, this is 0, this is 0, this is minus infinity, and this is also minus infinity, right? Now let's start. First element is true, right? So here our first condition is true, that is count 1 is 0. So what we will do? We will increase the count by 1 and make this E1 as 2, correct? Moving to the next element, this is 1. Again, we will see count 1 is 0 now, but count 2 is 0, right? This condition will become true. That means we will increase the count and make this 1. and the E2 will have 1 now. Correct? Let's go to the next element. Right? Count 1 is 0? No. Count 2 is 0? No. Is nums of I equal to element 1? No, because element 1 is 2 and nums of I is 1. Now going to the next one. Is nums of I is element 2? Yes. So what we will do is we will increase the count by 1, that is 2. Right. Now moving to the next element, we got the 3. That means the counts are not equal to 0. They are not equal to any other two elements. That means we have to reduce the counts. So this will become 0 now. Right. And this count will become 1. Correct. And now going back to the next element, that is 1. So here count 1 becomes 0. That means we will make this count as 1 and this EL we will initialize with 1. Right. But can't you see a mistake here? Right. We observe that our E2 we are tracking already for 1. Now again we are making E1 also to take care of 1. Right. Now what we have done is make both the E1 and E2 as 1. Right. But this is a huge mistake, right? We can't, track a single element that is 1 by using two variables, right? It has to be taken care only by one element. That means this algorithm is not perfect, right? We have to make some changes here because this algorithm is making to track a single element 1 by two variables, right? That means there is a slight change now in this algorithm, and which is if count 1 is 0, we are making the count 1 as 1, right? But what we have to make sure that my nums of I is not equal to EL2, right? Basically, if my nums of I is equal to EL2, then we don't need to do this, right? Similarly, here also we will put one more condition. If nums of I is not equal to EL1, right? This is the modification that we have to do. Okay. So what will happen is here we reached at 1, count was 0, but nums of I was equal to EL2, right? So this condition will become false and we will reach this condition that is increasing the counter, and we will increase the counter of this one. Okay, so this is the algorithm for the majority element if I have to find for n by 3. So we have to just use the Morse algorithm, make an extended version of it. Just remember this extra condition we also have to add now because we have seen that we want that only one variable should track of one element, right? So this condition will prevent, that other element is not tracking our element. Okay. So this is the approach, and as we are iterating through once only through this array, so the time complexity will become of n, and as we are not using any extra space, so the space complexity will be of 1. Okay, so this is the approach, and now we have discussed all the three approaches. We have extended the Morse algo also. Now let's go back to our code editor and let's start coding this up. Now we are back to our code editor. Let's see what we have given. So we are having an array nums and we have to return an array number, right? And we know that this array can have only maximum of 2 elements, that we know, right, by just doing the basic mathematics. Now let's start. What we have to do is we know only at max 2 elements are possible, right? So I will make a count 1 as 0 and count 2 as 0. Okay. And similarly, first element as, you know, one element, let's say EL1, and we'll make it minus infinity, and EL2 also will initialize with minus infinity. Okay, now let's start. What we have to do is we'll look through our array, right? That is I equal to 0 and nums dot length I plus plus, right? Now what we have to do? We have to check if my count one is 0. This I'm doing count one is 0, right? Now, if count one is 0, but also we don't want to track the same element again, we'll make sure that my nums of I is not equal to my element 2, right? That is, my element 2 is not tracking this nums of I, right? This I have put one check, and I will make this count as 1 and my EL1 as nums of I, right? So similar condition we have to use for my second element. So I will put an else if, right? I just copied the condition. And similarly, if my count 2 is 0 here, I don't want to track the first element again. So I will put EL1. And if that is the case, I will put my count 2 as 1 and EL2 as nums of I. Right. Now what else can happen is if my nums of I is equal to EL1, right? This can happen. That means I'm currently tracking my element and I can increase its count, right? And also my nums of I can be equal to my second element. This can also be the case. That means I'm nums of I is being taken care by element 2. That means I can increase its count by 1. Otherwise, that means my EL1 and EL2 are not equal to nums of I. That means I have got a one foreign element or a new element. That means I can decrease my current element count, right? So this is done, right? But one more thing you always have to remember about this Moore's algorithm, that EL1 and EL2 are possible candidates of majority element. Okay, Moore's algo doesn't guarantee that EL1 and EL2 are majority element. Okay, don't forget this. We have to check and verify manually. Okay, don't forget this. Okay, that is the trick. Okay, because lot of people forget that this is not a guarantee that EL1 and EL2 are majority elements. Okay, so what you have to do is now as we have to return an array, let me make a result array and initialize it with empty. So what you have to do is if count 1 is greater than 0, that means my EL1 can be the majority element and you can search this EL1 count. Okay, that is I less than nums dot length and I plus plus. Okay, and if this is greater than 0, I will regionalize with 0. And what you can do is if nums of I equal to your EL1, that means now we are actually basically checking the count manually. Okay, I will increase my count 1 plus plus. Okay, so this is the case, and if count 1 is greater than now my nums dot length by 3, that means what I can do is I can push it in my array. That is result dot push, and it should be EL1, right? Now talking about the next element, that is there can be a chance when my count 2 is greater than 0, right? That means my EL2 has a chance to be the majority element. So what I will do is I will just do the same for my EL2, that is same as EL1. We will check if it is greater than n by 3, that means it is eligible for majority element and I will push it. Okay, so this is the concept for the majority element. Now let's try returning this result and let's run this. Okay, now it is running. All the three test cases have been passed. Let me submit this solution and let's see if it is passed or not. Yes, it is passed. So this is the solution for the majority element. Always remember this. This Moore's algo doesn't guarantee you that EL1 and EL2 are majority. So what we have done is we have just checked the element manually and its count. If it is greater than n by 3, only then we are pushing to our resultant array. Okay. So that's it for now. Hope you have understood this concept, and if you have any doubts, just mention me in the comments. I will help you out. And if you have understood this algorithm, just mention understood. And that's it for this video. We'll see you in the next one. Till then, bye bye. Take care.